class. Today we are going to begin Chapter 8, which is called Regression Wisdom. It's really going to add a lot of depth to these regressions that we've been doing. And I would encourage you to go to this site right here because I'm going to be using it during these examples. So if you can, just kind of pause it and go over to the site and have it ready over to the side, so you can see what happens when I add points to plots and how the regression line is changed based on those points. It'll be very helpful. So outliers is what we're going to focus on during this. Outlying points can strongly influence a regression. Even a single point that is far away from the data can dominate the analysis. It can really change the line and it can really mess up your prediction. So any point that stands away from the others and lies outside of the overall pattern of other observations is called an outlier, and it deserves your special attention. Outliers generally have high residuals, but not always. So here we got a scatter plot that shows something was awry in Palm Beach County, Florida during the 2000 presidential election. I remember this back when it happened. A lot of you probably weren't even born yet. But there was one particular precinct back then where an unusual amount of people voted for Pat Buchanan. And it was called into question a lot during that election. I do remember it happening. And you can see how just that one precinct voting unusually high for Buchanan over here caused the regression line, caused the prediction of how many votes Buchanan would get compared to Ralph Nader to go up. So that one dot changed the prediction line that much of all those dots right there, of all the different precincts. So one can have a big effect. So the linear model doesn't fit points with large residuals very well. When you have a big outlier like that, it really messes up your linear model, and it messes up your ability to make any predictions based on that linear model. Because they seem to be different from other cases, it's important to pay special attention to points with large residuals. See if there might be something wrong with that point. Maybe the data is inaccurate. Maybe it was taken fraudulently. Maybe somebody cheated on something to make that data happen. It's something that you need to question and you need to look closely at and make sure it's legitimate if you have a big residual like that, if you have a huge outlier. So an observation is influential for a statistical calculation if removing it markedly changes the result of the calculations, or if adding it markedly changes the result of the calculations. But points that are outliers in the x direction are often influential for the regression line. So if you have a big outlier in the x direction, it causes big changes to the line. It causes your predictions to be a lot less accurate if that happened to be inaccurate or something. If that one outlier needs to be thrown out, it can really mess up your data. So they call it having leverage if it changes or levers the slope. Like if you change the slope of the line a lot, they call that having leverage. And unusual x values, like an x value that's far from the regular x values, really has high leverage. And let me kind of show you that. Here we have just kind of a normal regression line here, and it makes sense. It's strong positive correlation right here, 0.89. We got our regression line. But when you add another point that's kind of in the middle of these x's, even if it's kind of far off, like say it was right there, see, it changes the line a little bit, but not much, right? Because the point is still among all these x's. Even though it's pretty far away from the line, it's got a high residual. It doesn't change the line much. You notice that? But if I take a point, and I'm going to stay about the same distance from the line. Let's go way out here and get an x that's way far away. Watch how much it influences it. It brings it almost all the way down to it. So that's called having high leverage. And you have higher leverage as you get further away from the mean of the x's. The mean of the x's really affects it. So yeah, if you have a point that is way far away from all the other ones in terms of the x value, the horizontal value, it can cause really high leverage. And the closer in it gets to all the x values, the less leverage it has, even if it's kind of far away like that right there. See, it doesn't change it a whole lot. It does change it, but not a lot. Or this direction. It does change it, but not a ton. Changes it, but not a ton. But if you got one way out here, it really changes it. Like flips it way up. Or way up here, really changes it. So that's how that works. So this is a really good example here, this one with shoe size versus IQ. It's kind of scattered all over the place. Like if you look at this data, the regression line, there would be no correlation there, and there wouldn't be any regression line to make really. But if you were to put one person way far away, like somebody had a size 50 shoe, way out here, size 40 shoe, he has a huge influence on the regression line. And you can see, like if you put that one person with a shoe with a high IQ, it's telling you that as shoe size goes up, IQ goes up, which is not true. And if this giant person actually had a low IQ, it would make you think that as your shoe size goes up, your IQ goes down. He has huge leverage on this data. So you got to pay really attention to that. See, the residual is not even that big, and it has huge leverage on it. And let me show you that on here. So these have almost no correlation. They have zero correlation. They're just kind of scattered. But if I had one point way out here that was high, all of a sudden we've got a high correlation. Positive 0.80. See that? So if you have one piece of data that's way away from the other ones, it has a huge effect on the regression line itself, and you can't really trust it. So let's get rid of that. But if it was way down here, all of a sudden we have a negative correlation. So we went from no correlation to like a really high negative correlation or a really high positive correlation just based on one point. That's why you got to really be leery of a point that is way far away in the x direction. It has huge leverage and it really messes up the graph. This chapter 8, number 17, I'm going to do that on a separate video because that's a pretty long and involved problem. The same thing with the example with the children in that. I'm going to do that on a separate video as well because it's a pretty drawn out problem. And I just wanted to cover one more thing in this half of the slides before I go do those videos. And it's always, always check the residual plot when you're plotting a regression line. Because no regression analysis is complete without a display of the residuals to check and make sure the linear model is reasonable. If there's a curved relationship, it might not be apparent just by looking at it, but the residual will tell you if it's a curved relationship because the residual will have some sort of shape to it. So you want to remember, you want to see nothing in a residual. You want it to look kind of random. If you see some sort of pattern that's telling you that something's wrong with your regression line, it's probably not linear. So these residuals often reveal subtleties that were not clear from a plot of the original data. Sometimes the subtleties we see are additional details that help confirm or refine our understanding. The residuals, people call it the judge because it really makes you decide. It has the final say on if this is a good linear regression or not. If this data if you can use a linear regression on this data. So when you're deciding if data can be used and you can use a linear model on it, you always have to look at a residual plot. It is the judge. And here's an example of that. They called it getting the bends. And they have this scatter plot of the residuals against duration of emperor penguins. And this emperor penguin, the dive heart rate and the duration. And you could look at this and kind of think that a line going down would make sense here, right? But the residual plot, when you do it, and when I have residual plots, I always like to have a horizontal line at 0 to show how far away positive or negative it is from the middle. I can see a pattern here. Like this is kind of curving up like that. And you've got a very obvious pattern there, which tells me this is not an actual linear relationship. And if you look at it closely, you can kind of tell it's not linear. It's kind of like doing this right here. It's kind of curving down slightly, making a slight curve, a slight bend. So that is why you always have to look at residuals, because if you can't quite tell from the scatter plot itself, looking at the residual plot can really tell you, and it can help you come up to a judgment and come to a final conclusion on if the linear model is the correct model for this scatter plot. All right, that is it for the first half of Chapter 8. I will make another video out of the second half of the slides of Chapter 8.